Friends, today we will discuss the beta function 0 to 1 x to the power m minus 1 1 minus x to the power n minus 1 dx. This is the beta function and we will prove that is convergent for m and n is greater than to 0. Now let us define fx is that now 0 to 1 fx dx is equals to this. This is beta function taking first equation. Now let me define case first. What is case first? Case first is that if m minus 1 is greater than to 0, n minus 1 is greater than to 0, then fx is bounded and range of integration is finite. So the integral is proper. Hence it is convergent. Now case 2 is that m minus 1 is less than to 0 and n minus 1 is less than to 0. That is the most important fact because 0 to 1, m is in between, n is in between 0 to 1. In this case, x equals to 0 and x equals to 1 are the points of discontinuity. When we have point of discontinuity, then we split it up in integral in 0 to c and c to 1. We will take c is in between 0 to 1. Okay, when this type of thing and the convergence we will find. So convergence at x equals to 0 of this integral and the x equals to 0 is the point of discontinuity. So we will take gx. What is gx? Gx we will let 1 over 1 x to the power 1 minus 1 and fx which is given. Now by limit comparison test, fx upon gx is equals to 1. That is finite non-zero. So both have same nature. Integral of f and g both have same nature. So 0 to c g dx, but 0 to c dx, this will converge if m minus 1 is less than to m, that will m is greater than to 0. So if g is convergent, then f is convergent too for m is greater than to 0 by limit comparison test, right? Now what is the convergence at x equals to 1? Because of 2 point of discontinuity we have, so the integral 0 to 1, then there exists this, and now c to 1 f dx is same with same process as the point of infinite discontinuity. N minus 1 is less than to 0, fx equals to x to the power m minus 1 upon 1 minus x to the power n minus 1, right? Phi x is given, then taking the limit of this which is finite number, and if it is a finite number, so c to 1 phi dx is convergent if n is greater than to 0. Okay, now integral of this is convergent if n is greater than to 0. So this will we find that integral of 0 to 1 f dx, how it is, because c to 1 is the limit and there exists f to 1 1 to c,